Hello viewers, hope you all are having a good day. This is Soham from SNS Learning and I'm wishing you to have a hassle-free learning ahead. In this tutorial, we're going to learn about relational database normalization. What I felt was, before diving directly to understand what database normalization is, if we can have a solid foundation on why database normalization is required or why database normalization came into picture, then it would really help us digest the actual concept of normalization very easily. So let's get started. As you can see in the screen, I'm going to explore the entire concept by giving you a quick glance or definition about RDBMS and the common design disasters that basically leads to the concept of database normalization. As you can see in this screen, I actually want to explain in a very layman terms what a relational database is. So you can see in the screen there are two tables, one is employee and another is project. So in a database technical terms, these tables are called relations. So employee is a relation, project is also a relation. The records in each of the table or the relation is basically referred as tuples. So each and every record of a relation is a tuple. So you can say a relation may consist of multiple tuples. All the columns like employee name, employee number, employee contact, these are called attributes. So these are all attributes of relations. So if we want to have a summary, then a relational database is nothing but a collection of relations. If we are marking it as R1, R2, etc. So a relation R will basically a summation or collection of R1, R2 till Rn, where n can be any integer. Attributes, it's nothing but a column of a relation. Tuples, like I have said, it's nothing but a records, and relational database is a collection of relations. So this is a quick definition of a relational database. Okay, let's move on to the next slide. So these are the main design disasters that basically leads to the concept of normalization, or to be honest, these are the design disasters that are very common that the developers or the data modelers are prone to make. And normalization is a medicine of these disasters cureness. Yes. So the first design disaster is semantics of the attributes. Second is reducing the redundant information. This is very crucial. Third is reducing the null values in records. Four is disallowing the generation of spurious tuples. So as we will proceed, you will observe that point number 3 and 4, that is null values and spurious tuples, are basically byproduct or side effects of this reducing the redundant information part. So let's understand the semantics of the attributes first. So semantics of the attributes is a very basic foundation of designing any relational database. So it basically says that always design a relational schema so that it is easy to explain, or in a simplified way, the relation should be self-explanatory. Do not mix up entities and create one relation. Ambiguity should be maintained in relation. So you can see the first relation or first table in this database is employee. One can easily understand from the name of the relation itself that what kind of information it can contain. If you see the attributes of the relation, employee number, employee full name, employee date of birth is there. So all information related to employee is present there. Now come to the second employee table. If you observe it carefully, this is also contains information about employee only. But look at carefully all the columns. The first column is employee number, second is employee full name, third is employee date of birth, and the fourth one is employee age, and the last one is employee last name. Now, if you think it carefully, if I have an employee date of birth, I can easily conclude his or her age. I do not need to have any other attributes which explicitly says the employee's age. Why I'm saying this? Because we may end up having inconsistent data. Say for example, take the first rows where employee number is 123. His date of birth is 26th of February 1991 and his current age is 29. Let's say for example, by any mistake, someone updates it instead of 29 because of some typo, he mistakenly updated it as 39. So basically that information would confuse anyone. It would lead to wrong calculation of data or wrong calculation of some KPIs, etc. In the same way, if you think the last column, which basically is employee last name, when I have the employee full name, I don't need to have any separate column which explicitly said what employee last name is. I can easily retrieve or I can easily calculate the last name column from the employee full name table. Now come to the third table, which is employee department. Now if you see the name, it is employee department. So basically it conveys the information of each employee and his or her associated department. Now the rule says do not mix up real life entities into one. Here employee is a real life entity, department is also a real life entity. So to create a base relation, the rule is do not mix this up. So if you see this table, say for employee 123, his department number is 10 and department location is Egypt. So this is one of the common disasters that the data modeler makes. We will see how to remove this and what are the problems that could be arise from these kind of disasters. Let's move on to the next slide. So this is the most important concept of normalization, and this is the most dangerous mistakes of any relational database design. So reducing the redundant information. Now look carefully at this employee department table. So in this kind of disasters, there are mainly three kinds of anomalies that we used to have. Number one is insertion anomalies, second deletion anomalies, and the third one is update or modification anomalies. So we will see one by one what are these actually. So first one is insertion anomalies. So this is one of the relation which is employee department, like I have just explained a few minutes ago. It basically holds the information of employee and the employee's associated department number and the department name. So Brian is an employee who is working for department number 10, and department number 10 deals with research. So now let's have a look on some scenarios so that it would be easier for us to understand what the anomalies actually are. So scenario 1. We need to insert a new employee in this table who has just joined the company and is yet to assign a department. It's a very common scenario. When an employee joins an organization, it may happen that the employee in his first day haven't been assigned any department yet. So it will take like 2 or 3 days to assignment to happen. So let's say for example the employee is Omar, the last tuple of this relation. So his employee number is 7789 and his date of birth is given. Now as we do not have the department number right now, so either we have to keep department number and department name as blank, or we have to give it some default values. So in this case, I am keeping it as null. Now let's think in this way, like on a particular day, a company hired like 500 of employees. So 500 rows will be created here, and 500 null records will be created in department number and department name column, which is a very bad design. Now, what are the problems that could be there associated with these null values? We'll see later. Consider this scenario 2. Now, need to insert a new employee in this table who has just joined the company and have assigned to innovation department. Now, this is another scenario. We can see that Philip and Omar both have joined the company and have already assigned a department which is called innovation. Now, to insert these two employees in employee department table, I have to make repetition of this department name innovation same time, or the number of times, the number of employees that those have joined. Say for example, if 100 employees join the company in the department of innovation, so I have to enter, or I have to make an entry of 100 employees, and I have to make 100 times this particular information in every record, like Philip 30 innovation, Omar 30 innovation, say for example X 30 innovation. So this 30 and innovation column is basically a redundant information which is giving me. Now let's come to the next scenario. The company has started a new department called digital transformation. An employee are yet to assign in the department. This is very crucial example. See, it may happen that a new department has just started and employees are yet to assign to that department. Now, to update this information, I have to have this department name information in this table, because my design is in that way only. So let's consider this highlighted row. The department number is 50, department name is digital information, but as no employees has been assigned yet, I cannot fill any information in the employee portion. And as you know, or as you can see in this table, employee number should be the primary key, because by seeing the employee number, I can uniquely identify each and every tuple in this table. And primary key cannot be null. So if we go by this design, this scenario 3 cannot be consumed by this design. So these are the 3 insertion anomalies where we have just seen the problems that could be arised due to this design. Now let's come to the next screen. This is the deletion anomalies. Now look carefully, this relation, this is also employee department table. It's the same table that I've used to explain the insertion anomalies. So let's consider this scenario. Omar has left the company, so the company needs to update the tables accordingly by deleting Omar's information. So this is a very common scenario that a particular employee resigns the organization, so the company needs to update the database accordingly. Now let's say Omar was working in digital transformation department. Now as he have resigned, company needs to remove his information. Now see the design. If I remove this information or remove Omar's information, I have to delete the entire row. And if I delete this, I lose information about this department of digital transformation. Let's say for example, I am deleting this record. So it basically means that the company's employee department table will convey that there are no department called digital transformation exists in this organization, which basically conveys a false information. So this is the deletion anomalies. Let's come to the next anomalies, which is update or modification anomalies. It's almost same as deletion anomalies. Now we'll see this. So this is again another instance of employee department table. Let's directly come to the scenario. So here the scenario is the marketing department has recently been renamed to marketing and strategy. This is a very common scenario. So the company needs to update this in their database. So there are 3 instances of marketing related records in this table. If you see the employee, those are working in marketing department are Chris, Omar and Iman. Now if I am going to update marketing to marketing and strategy, I have to make this update in these 3 records, but I need only to update the information that marketing is changed to marketing strategy, and for this I have to make multiple updates. Now this is a table of merely 5 records, but in actual scenarios there are millions of records in one relation. So just think that one rename of a department would cause you to update millions of records, which obviously are not a good design. So this is update or modification anomalies that arises due to bad design. Now coming to the next anomaly or the problem of a bad design of a relational database is the null values in records. Now as I was saying that these are the byproducts of the 3 anomalies that we have just seen. So if you see this table is very familiar that I have shown you in the first slide, that say this is the condition after the insertion anomalies. Say Omar, we have just inserted the information about Omar, but as we do not know to which department Omar is going to assign, so we are keeping this record as null. Now to be honest, null has a very unpredicting behavior in nature. So in a real life scenario, this null means that department number and department name is unavailable at the moment, or it can be interpreted as employee Omar is yet to assign a department, or department information is known but it is not updated in the database yet. So it basically becomes ambiguous. And one more thing is, in relational database, we often required multiple relations to be linked together by means of joins. We will see later what join is. And when doing a join between relations, this null could be dangerous because we do not know how the join would behave because of null values. Obviously, it would not behave as we are expecting. The next one is disallowing the generation of spurious tuples. Now, this is also a byproduct of those 3 anomalies. So let's consider the first table, employee department table. It's very familiar. I have used this to explain the update or modification anomalies. If you see the row number 2, 3 and 4, Brian, Omar and Iman are working in marketing department. Let's say for example, I have 2 relation in the office or organization relational database. One is employee department, another one is department locations. So as the name suggests, the first relation is basically employees and their departments, their associated departments, and the department location table conveys the information about department and the location where the department is situated. Now let's say I need the information of employee and the associated department with department location. In employee department table, I do not have the location information, but in department location table, I have the department location. So I need to join these 2 relations. Now look at the third table or the last table in this screen. If I join between these 2 through department number to retrieve the corresponding department location, see the record of Brian. Brian is working for department number 10. Now go to the department location table. Department number 10 is basically operated from two different locations, Russia and India. Now if we join these two, you will get two records where department location information will be conveyed for sure, but I'm going to repeat these four attributes, employee name, employee number, date of birth and department number, multiple times, which is unnecessary. I don't need these four attributes to be repeated again and again. Now let's consider in a large scale, it may be possible that a particular department may be operated from hundreds of cities. So if an employee is associated with a particular department which operates from hundreds and maybe thousands of cities all over the world, so if I join these two with this design, I'll get 1,000 records. Only differentiation would be the location of department, but all the four attributes, all the employee related attributes would be repeated. So this is a problem of generation of spurious tuples. Now it has a very large downstream effect. So we will get to know it later. For now, I think we all have acquired a basic understanding of design disasters that is very common to relational database, and this is the design disasters that basically leads to database normalization. We will see in the next tutorial how database normalization can eliminate these kinds of problem through some guidelines, through some predefined notion. So thanks for watching. Hope you have enjoyed the video.